In this video, we will be covering projectile motion as it applies to physics. Now, a projectile is an object upon which the only force that acts on it is gravity. And so there's a variety of different examples of projectiles. You can drop an object, you can shoot a bow and arrow, you can throw an object, but by definition, a projectile has a single force that acts upon it, and that's the force of gravity. If there were any other forces acting upon the object, then that object would not be a projectile. So we're going to move forward looking at how to approach projectile problems. And when we look at projectile problems, some of the characteristics we'll need to look at is going to be the horizontal and the vertical components of the velocity, and then the horizontal and the vertical displacements. And as we begin solving some of the various projectile problems, I have put this slide here for you to refer back to so you can see some of the basic equations that will be used to approach projectile motion problems. So here we have a diagram of a projectile, and so as you can see with the projectile, it moves in two dimensions, and so it's going to have components like a resultant vector. It's going to have the horizontal component, and it's going to have the vertical component. And so that when we look at projectiles, the horizontal component never changes. It covers an equal displacement in an equal time period, meaning that the initial horizontal velocity equals the final horizontal velocity. In other words, the horizontal velocity will be constant. And the reason for this is because gravity does not work horizontally to increase or decrease the velocity. However, the vertical velocity does change, and so together when we look at the horizontal and the vertical components, we look at their magnitude and their direction, together we can calculate a trajectory path, and this path will be parabolic in nature. Now here we have an example problem. We have a plane that's traveling with a horizontal velocity of 100 meters per second. It's 500 meters above the ground. At some point, the pilot decides to drop off some supplies to a designated target below. How long is the drop in the air, and how far away from the point where it was launched will it land? So as we begin, let's go over what we know. Now, the first thing we know is we know that our horizontal velocity was 100 meters per second. We know the height was 500 meters. And we know that our initial vertical velocity was 0. Our gravity is 9.8 meters per second squared, and because we're dropping, it's a negative 9.8. What we do not know is our time period, or how long the drop is in the air, and we don't know how far away from the point from where it was launched it will land. Let's begin with identifying our time. Now, in order to do this, we're going to take 1/2 times gravity times time squared. So we have negative 500, because that's our height, will equal 1/2 times our gravity times time squared. This is our x. Now we're going to solve for our x squared, and when we do so, we end up getting 10.1 seconds that the drop was in the air. Now, the next thing we have to do is determine how far away from the point the launch will land. To do this, we're going to take our horizontal velocity, which was 100 meters per second. We're going to multiply that times our time that we just calculated, which was 10.1 seconds. Multiply that out, and we get 1,010 meters. Sometimes we need to come up with angles when we do projectiles, and so here I've given you some various equations of motion that deal with the angles, and we'll look at some example problems. Now here we have a three-part problem. We have a place kicker kicks a football with a velocity of 20 meters per second at an angle of 53 degrees. We are asked to solve for three problems. How long is the ball in the air? How far away does it land, and how high does it travel? Now in order to do that, we need to first do our little diagram. Now we know that our angle is 53. We know that our velocity is 20 meters per second. Now I need to come up with my vertical and my horizontal sides. Now let's go ahead and do our horizontal. Now in order to do our horizontal velocity, we're going to take our initial velocity times our cosine of our angle. We were given 20 as our velocity in the problem. That's 20 meters per second. Cosine of 53. And so we get our horizontal as right across here being 12.04 meters per second. We also need to come up with our vertical velocity. To get that, we would take our velocity times our sine of our angle, so 20 times sine of 53. We get this area right here as 15.97 meters per second. Now that we have these components, we can move about to solve part 1, how long is the ball in the air? Okay, so we placed our components in here we got from our previous slide. We have our horizontal velocity is 12.04 meters per second. We have our vertical velocity is 15.97 meters per second. We can now go about solving how long the ball was in the air. To do this, we'll calculate our time as being, we have our vertical velocity times time plus 1/2 gravity times time. Now we know that our initial y is going to be 0. We know that our vertical velocity was 15.97. Our time is our unknown. We've got t here. 1/2 times 9.8 is 4.9. Again, time is our unknown. We rework our problem over. We get negative 15.97 t equals negative 4.9 t squared. Then we're going to work and divide each side by t so that we get 15.97 equals 4.9 t. Divide each side by 4.9 and we get our time was 3.26 seconds. That allows us to move ahead and to determine how far away the ball landed. Now to do this, we're going to take our horizontal velocity times our time. Our horizontal velocity we calculated on a previous slide as 12.04 meters per second. We're going to place that in right here. We also just calculated our time as being 3.26 seconds. We're going to multiply this out, and so we have a distance of 39.24 meters as far how far away the ball landed. Now we're asked to determine how high the ball traveled. Now remember, the ball is going to go up and it's going to come back down. And for it to go up and come back down, it took 3.26 seconds. So we're just looking at going up, and so we're going to cut our time in half. So in order to calculate how high it travels, we're going to take our vertical velocity times our time plus 1/2 times gravity times squared. We calculated our vertical velocity as 15.97. We took our time and divided it in half because we're only looking at the up part. We're not looking at the time it took for it to come back down. That's why we have 1.63. So 15.97 times 1.63, that's this part of the equation, plus 1/2 of gravity, gravity's 9.8, times the time squared. Put that in here, work out our math, and so we calculate that the ball would have traveled 13.01 meters high.